Hey everyone, today I'm going to show you how to create a movie recommendation app using Dgraph, Modus, and Next.js. In the description below, you will also find the accompanying blog post, as well as the repo to the final code for this project, so go ahead and check those out if you'd like. Now, before we get started, let's take a look at the app we're going to be building. So this app lets users search for movies, view movie details, and get AI-powered recommendations based on the movie they're currently looking at. To build it, we'll use a public read-only movie dataset provided by Dgraph. Now, this project is a great demo of how Modus simplifies integrating Dgraph's graph database with an LLM. So let's begin by setting up our project. Now, to do this, we first need to install the Modus CLI. And before doing this, you need to make sure that you have version 22 or above of Node installed. Now, in order to install the CLI, just run this command. And this will install the CLI globally so you can access it from any directory. Now we can create a new Modus project by running the following command in our terminal. This command prompts us to choose between Go and assembly script for the language of this project. For this example, we're going to be using Go. We'll then be asked to name the project and whether or not we want to initialize a Git repository. And then Modus creates a new directory with the necessary files for our project. So let's go ahead and open our project in our text editor. And if we open up our terminal and run this command, modus dev, it will build and run the app locally in development mode, and it will provide us with a URL to access this app's generated API. So if we visit this local endpoint, it will give us an interface that allows us to interact with the app's API, and we can test our functions locally without having to deploy it every time we make a change. So let's configure our project to use Dgraph and our AI model. To integrate an LLM and connect the project to Dgraph, we need to configure the modus.json file. This file acts as the manifest for the Modus project, defining the available models, endpoints, and data connections. So add the following to the modus.json file. Now here, endpoints defines the GraphQL endpoint for the Modus project. This is where your backend functions will be exposed. Models configures the LLM that we're going to use for generating recommendations. So in this case, the source model is the model provided by Hugging Face, and the connection is set to hypermode, which ensures that Modus handles communication with the provider. Finally, connection sets up the Dgraph connection using the play configuration. The base URL points to the read-only dataset hosted on Dgraph's public instance. It's worth noting that we're using the HTTP endpoint here because the gRPC endpoint is not exposed for this public example. But for production use, the recommendation is to use the built-in Dgraph client for better performance and feature support. So now that our manifest is set up, let's go over how to write our functions, which I've already pasted into our file. So in Modus, functions are defined in the main.go file, which we're currently in. Now, in order to export a function from this file, which makes it externally accessible, all you need to do is capitalize the name of that function. So for this example, we're going to have two exported functions: fetch movies with pagination and search, and fetch movie details and recommendations. So now we're going to break down how each of these functions work, as well as their helper functions. But before doing so, let's take a look at the imports and why we need them. So first, we have the standard library. So we have encoding/JSON, which is used to parse and encode JSON data. We have FMT, which provides formatted input and output functions like printf and sprintf. And then we have strings, which is a library for string manipulation tasks, like trimming white space. And then we have the Modus-specific packages. So we have HTTP, which is for making HTTP requests, which we'll use to query Dgraph. We have models, which helps us integrate AI models defined in our modus.json file. And OpenAI, which is a package specifically designed for working with OpenAI models in Modus. Now that we understand the imports, let's move on to the functions. Starting with the fetch movies of pagination and search function, this function highlights how Dgraph simplifies querying complex interconnected datasets. So this function is designed to fetch a paginated list of movies from the Dgraph database, along with their related details like genres, actors, and directors. It also supports optional filtering based on a search term. So let's break this function down step by step. First, we calculate the offset, and this determines where the query should start fetching results. So for example, on page 1, the offset is 0, so the query starts with the first movie. On page 2, the offset is 10, because we're going to show 10 items per page. So we'll skip the first 10 movies, and this allows us to retrieve 10 items per page, ensuring that we don't duplicate any of the items. Next, we dynamically build the query using Go's fmt.sprintf, and here's what this query does. It filters for movies, so the func has initial release date, ensures that we're fetching nodes that represent movies with release dates. For implementing pagination, the first 10 specifies that we only want 10 movies, and the offset decides where to start. This sorts movies by release date in descending order, so the newest movie is going to appear first. And then finally, this gets replaced by the result of the build search filter function. This is a helper function defined in this file, and it dynamically adds a filter if a search term is provided. The query also specifies the fields to retrieve. So each movie's UID, name, and initial release date are retrieved, as well as nested details like genres, actors, and directors. Dgraph's graph structure allows us to include all this related data in a single query. Finally, we call execute dgraph query to run the query, and this function sends the query to dgraph, retrieves a result, and returns them as a JSON string. So in summary, this function combines pagination to fetch results in chunks, sorting to display the most relevant data first, dynamic filtering to tailor the results based on the user input, and nested queries to retrieve related data efficiently. Now, as I mentioned, we call the execute dgraph query function to run the query. So let's move to where we have this function defined and take a little look at it. This function uses Modus's HTTP client to send the query to dgraph's public endpoint. It's worth noting that since this is a public dataset, we use the HTTP endpoint instead of the gRPC. For production use, the gRPC client provided by Modus is a better choice. It offers improved performance and some additional features. Now let's move on to the next function, fetch movie details and recommendations. This function is a great example of how dgraph and Modus work together to combine internal data with AI-driven insights. It retrieves detailed information about a movie and generates tailored recommendations using an AI model. So let's break this function down step by step as well. First, the fetch movie details function queries the dgraph database to retrieve details about a specific movie, things like its title, genre, actors, and director. Next, the parse movie name function extracts the movie's title from the JSON response, ensuring it's ready for the next step. Using the movie name and user input, the generate prompt function creates a natural language prompt for the AI model. And the generate recommendations function invokes the AI model we configured in our Modus Manifest to produce personalized movie recommendations. And then finally, the movie details and AI-generated recommendations are combined into a single JSON response, which can be easily used in the front end. Okay, so now let's take a closer look at some of those helper functions. First, the fetch movie details function. So this query uses dgraph to fetch data about a movie in a single call. It's efficient and it avoids the complexity of multiple database queries or joins. Next, we have parse movie name. So this ensures that the data returned from dgraph is parsed correctly so that we can extract the movie title and we can use that later on when generating the AI prompt. And then finally, that leads us to generate recommendations. And this function uses Modus to interact with the AI model. The prompt guides AI to produce relevant recommendations based on the title we pass into it, making the results more accurate. So now that we've written these functions, we can test the backend locally using the API Explorer. So if we go back to localhost 8686/Explorer, which we checked out earlier, we can see our two exported functions, fetch movies with pagination search, and fetch movie details and recommendations. So we can select a function, provide the required arguments, and click run to see the results in real time and test what we built locally. Okay, so that's a quick overview of how we can combine dgraph and Modus to make this AI-rich backend and how we can test it locally. So now let's integrate this backend into our front end. For this project, we'll be using Next.js, but the same concepts can easily be adapted to other front-end frameworks. So the main connection between the front end and the back end here happens in our actions.ts file. And this file acts as a utility layer handling all the communication with the backend through its GraphQL API. So first, let's walk through the core function of this file, fetch query. This function simplifies sending GraphQL queries by taking a query and its variables as parameters, and it also handles errors and parses the response, making it reusable across our application. So all of our backend queries are going to go through this function. So now let's take a look at how we might use this fetch query function to fetch a list of movies. So let's look at our fetch movies action. And this action formats the GraphQL query and sends it to the backend with pagination and search parameters, and then processes the response and formats the data for easy use in the front end. So let's move into the page that this is used. So we see this page imports and uses the fetch movies action, passing in the page number and search query if one exists. Once the action returns the movies, the result is passed into the appropriate component, and the component will display it from there. Now, this is a really quick overview of how you can plug in our Modus backend to a front end, and we can test this out locally with our backend. So to run the front end locally with our backend, we have to ensure that the backend is running locally first. So if we move back into our backend directory and run modus dev, this will ensure that our backend is running locally. Next, we need to ensure that the endpoint used by the front end is the one provided here. So if I open up my env file in the front end directory, we see that it is in fact this endpoint. So now we can open up a new terminal. Let's move into our front end directory and run npm run dev. Now if we visit localhost 3000, we can see our application is running locally using our backend. So we can search for movies using the search bar, click into a movie, and we'll see our AI-generated recommendations. And that's it for today's video. As I mentioned in the beginning, the related blog post, as well as a repository with the final code for this project, is linked in the description below, so feel free to check those out. If you have any questions, leave them in the comments below, and thanks for watching. Bye.